Hello, I'm Patty Simpson with Simpson Math. In this video, we're going to describe the variables in our scenarios. So in statistics, it's really important that we're able to describe our variables and our data that we obtain, so that then we know what math, what statistics we can find from that data that we've obtained. So we're going to describe our variables in a couple of examples here. Every time we describe our variables, there are three parts to describing the variables. First, is it qualitative or quantitative? Then, is it discrete, continuous, or neither? And the third part is the level of measurement that the variable is at. So, first thing we need to actually do is decide what the variable is. What is the data that we are collecting? So let's read this first scenario and see if we can determine what that variable is, or what the data is that we're collecting. A sporting goods store is interested in determining the location of residence of their customers. The store asks every third customer to provide their zip code. So think about you being the researcher, the one that's collecting the data. What is your data going to look like? What is it that we're collecting from each of our customers? And it tells us that we are collecting from each customer the zip code. So here, the variable that we'll be describing is the zip code. The variable, or the data, is the zip code. Now we need to decide, is zip code qualitative or quantitative data? Remember that qualitative data is a category or a quality, whereas quantitative data is a quantity, it's a measurement, it's a count. Well, in this case, if I want to ask the zip code, I'm really just asking for my customers for the location of their home. Like when I give my zip code, it tells people that I live in North Temple. So that zip code just really means the location or that place of your home. And that's a category. So therefore, our zip code is a qualitative variable. So zip codes are qualitative variables, because it's just that location, because locations are a category. Then we need to know if it is discrete, continuous, or neither. Remember that these words discrete and continuous refer to quantities. We need a number in order to be able to decide if it is discrete or continuous. All of our qualitative data is neither. So because this is qualitative, it is neither continuous nor discrete. And then last but not least, the level of measurement here. The level of measurement is just nominal. We cannot do anything with these, our math. We can't do any math with zip codes. We can just count how many people are in each area of town. I can't really even put it into a meaningful order. Saying 76501 is not greater or less than 76502. Those two zip codes, I can't put it in some sort of meaningful order. So it wouldn't be ordinal, it would just be nominal. So zip codes there are just nominal data. And that tells me then later that when I'm trying to find my statistics, when I'm trying to do some math with it, I can't add these zip codes up and divide to find a mean. The only thing I can really do with them is find a proportion or a percent. Let's look at this other scenario. A factory manufactures pistons. The production manager wants to make sure the radius of the pistons meets specifications. The manager inspects 20 pistons from the production line. So think about what we're going to be. We're the ones inspecting, we're looking at it. What is it that we are recording if we're checking on the radius of the piston? We're going to be measuring that radius, right? So here the variable is the measurement of the radius. The variable is the measurement of the radius. And again, let's decide, is that a qualitative or a quantitative variable? Is it just a category, or is it a count or measurement? Well, we kind of gave it away when we described the variable, because it says it's a measurement. Since it's a measurement, it is a quantity. It's a quantitative variable. So, radius or measurement is a quantitative variable. We're going to record numbers. We're going to record a measurement. Then, is that discrete, continuous, or neither? Well, it is a value, so we are going to decide if it's discrete or continuous. When we measure things, a lot of times we can get more and more exact. So remember that discrete is a distinct or a countable measurement, whereas continuous is any number within an interval. And when we measure the radius, I could measure it more and more precisely. Maybe I measure it in centimeters or millimeters. I can get it more and more precise. And so therefore, this is a continuous variable. So the measurement can be measured more and more precisely, measured with more and more precision. Or you could find a radius in between. If you give me any two numbers, I can find a measurement in between those two. Can be measured with more and more precision. So the radius, so the variable is continuous. You need to be able to write with complete sentences when you answer these questions. Part of statistics is being able to communicate your findings. And so being able to write with complete sentences is important. And then last but not least, we need to decide on the level of measurement. Is it nominal, which means we can only count the things? Ordinal, where we can put it into some sort of meaningful order. Interval, where we can find differences between them, but there is no true zero. Or ratio, where we can pretty much do all the math with it. There's meaningful differences, addition and subtraction, as well as multiplication, and there is a true zero. So the first thing I do is I realize that it's quantitative. Since it's a quantitative variable, it's either going to be an interval level of measurement, or it's going to be a ratio level of measurement, those two higher levels of measurement. Then I ask myself, is there a true zero or not? If I say my radius is 0, is there an absence of something? And sure enough, if the radius is 0, that means there's no piston there. There's an absence of a piston. So since there is a true 0, this is a ratio level of measurement. The level of measurement is ratio. And I can perform all math that I want to be able to perform on that level of measurement. So there are some examples of describing the variables. Anytime we describe variables, we're going to have 3 parts: quantitative versus qualitative, discrete, continuous, or neither. And then the third one is that level of measurement. Math Made Simple is Simpson Math. Thanks for watching.